Here we're going to talk about the real numbers and number line. Let's see what you're going to learn. We'll be able to explain the real number system. We will also able to generate a graph of rational numbers on the number line. We will able to tell which of the two real numbers is smaller. We will also able to determine the opposite of a real number, or it's also called additive inverse. We will able to determine the absolute value of a real number also. Let's get started. Let's first look at what are natural numbers. Natural numbers are just counting numbers, the numbers that you use in everyday's life. So your number starts from 1, 2, 3, 4, 5, 6, and so forth. The key thing is to remember that you must begin the number set with 1. The next set of the numbers are called the whole numbers. To remember what kind of numbers will be in a whole, you want to look at the 0 in the word whole. That should remind you of the number 0. So beside the numbers which are in natural numbers, we're going to include the new number 0, and we call this set as a whole number. Whole number must begin with the 0. 0, 1, 2, 3, 4, 5, 6, and so forth is a whole number. Let's look at the integers now. Integers are the numbers which have positive in them, negative in them, and the 0. So all the numbers which has positives, negatives, and 0 will make your integer set. So here's an example. -4, -3, -2, -1, 0, 1, 2, 3, 4 are the example of the integers. Let's talk about the rational numbers. Rational number means it's the ratio of two integers. The restriction we have is that we cannot have the denominator to be 0. Anytime the denominator is a 0 for any fraction, the entire things become undefined. I'm going to show you different kinds of rational numbers, including the integers and the fractions and the decimals. All the integers, if you put the 1 underneath, can represent the ratio. So every single integer is also a rational number, including the 0, because you can write 0 as a 0/1. You can have any kind of fraction also in your rational number set. It could be a proper fraction, improper fraction, or a mixed number. Because fractions can be changed into the decimal, we also have to include the decimal in the part of the rational number. There will be two kinds of decimal that will be allowed. The first type is called the terminating decimal. The example is -3/4 equals -0.75. Terminating meaning it stops at some point. If it doesn't stop, then it must repeat. The example for that is 5/9. If I change in a decimal, I'm getting 0.5 repeating. I can write that using a bar, 0.5 bar. So two types of decimals that are allowed under the rational numbers are terminating decimal and a repeating decimal. Before I go over the irrational number, let's just review. We talked about the natural number, a positive number. 13 is a natural number. 13 is also a whole number. 13 is also integer. And 13 is also a rational number. If I give you the number 0, then you want to start from the whole number. 0 cannot go into natural. 0 will be an integer, and 0 will also be a rational. If I give you a negative number, a -8, you want to start from the integer. -8 is also a rational. Keep in mind, negative numbers are not allowed for whole and natural. If I give you a fraction, then that's only going into a rational. If I'm giving you a decimal, either terminating or repeating, it's only going in a rational. You can't have that in integer, whole, or natural number set. Let's talk about the irrational numbers now. For irrational numbers, I'm going to show you the radicals or the decimals. Now keep in mind, the decimals we allowed earlier for rational numbers were terminating and repeating. So for irrational numbers, I'm going to allow the decimal which doesn't terminate or repeats. Here's an example. Square root of 3, if you put in a calculator, you will get 1.732050808, and it keeps going. If you look at this decimal, it's not stopping and it's not repeating. Exactly same thing has happened with the radical 12 or square root of 12. Also, if you notice, the 3 and the 12, they're not perfect square radicals. So anytime you see that they're not perfect square radicals, this is the kind of decimal you will get. So remember, for irrational number, we're looking for not terminating and not repeating decimals. Now let's review everything we have talked about so far. Natural numbers are only positive numbers. Whole numbers are 0 and positive numbers. Integers are 0, positive and negative numbers. Rationals are 0, positive, negative numbers, fractions and terminating decimal and repeating decimal. Irrational numbers are square root, which are not perfect square, or if you're having a decimal which doesn't stop and repeat. Every single number that you see here will be real. Something which is irrational, keep in mind, will not go anywhere under natural, whole, integer, or rational. That's why I have it on my right side of the screen. So every single number you see up here is real. And this is how you classify the real number system. Let's talk about the opposites or additive inverse. For this one, to explain, I'm just going to use a number line. On the right side of the number line, I have a positive numbers, and on the left side, I will have my negative numbers. We already know that these are the integers. We just learned that. What do I mean by opposite is that they're equal distance from 0. So 3, which is on my right side, will have a same distance from 0 as the negative 3 on the left side. So the distance between 0 and 3 and 0 and negative 3 is exactly same. Same thing goes with the negative 1 and 1, and same thing goes with the negative 2 and 2. These are called the opposite numbers. I can use the negative sign to represent opposite also. It's also called additive inverse, just in case if you hear that word. So here I'm writing opposite of 2 by putting that negative sign, and then the answer becomes negative 2. Also, I can show opposite of negative 2 by writing negative times negative 2. That's why negative times negative, the number becomes positive. Now keep in mind, negative times negative is positive if the parentheses is used. Ordering of the real numbers. For any two real numbers A and B, A is less than B if A is to the left of B on a number line. So I'll show you that with the number line, but any number which is on the left will always be smaller number. Keep that in mind. It's always true for any real number. So the sign that I'm using is A less than B. Now, before we graph, just keep in mind what we just learned in a previous slide. If I remember the rule, then 0 is on my left side of 1. Therefore, 0 is less than 1. Negative 2 is on the left of 0. So negative 2 is smaller than 0. So you see that how the rule works. Now I'm going to show you these numbers, and I will put them, let me get the pen, and we'll put them on the number line. So first number is a negative 2.5, which is a decimal. So this number will go right there in between. It's basically half of here. So if I make a half a line right there, this represents negative 2.5 right there. The second number I have is a negative 3/4. Negative 3/4 is a proper fraction. The value is less than $1. Because of the negative sign, I am between the 0 and a -1. I'm on the other side. If it was positive 3/4, then my number will be between 0 and +1. Keep in mind, these are the number of parts that you have to make first. I already draw the 2 vertical lines, so I'm going to draw 3 more vertical lines, and that will make 4 equal parts right there. 1, this is 2, this is 3, and this is 4. Which one I want is the third one. You have to look on the top, which is my third line. This is what will be negative 3/4. So you're getting closer towards -1. Because imagine if the top number instead of 3, it was 4, -4/4 will reduce to -1. Let's try one more on the positive side. 7/3, it's an improper fraction. Anytime improper fraction is given, you must change into a mixed number. Because right now I don't know between what two numbers I should plug this in. So 3 goes into, first I'm just going to copy the 3. 3 goes into 7 twice, and that is going to be 6. 7 minus 6 will be 1. So that's how I change into the mixed number. This is 2 and 1/3, meaning more than 2 but less than 3. So first thing I realized that I'm right here, somewhere in the middle, 2 and 3. Now look at the denominator, 3 equal parts. So I'm going to draw 2 lines that will give me 3 equal parts. This is 1, this is 2, and this is 3. Which one you want is the first one. The first line is your 2 and 1/3. This is how you can graph on a number line without the ruler. Let's talk about the absolute value now. 3 things before we start learning on the absolute value. The absolute value word has to do something with the distance. Keep in mind. Absolute value cannot be negative. The reason why, because the distance cannot be negative. You cannot drive negative miles. Starting point in the number line, it's going to be 0. For us, I'm going to put in the center of my number line. Let's make a number line. Here's my number line, the 0, and I have +4 on the right side, -4 on the left side. The absolute value symbol is the 2 vertical lines. So if I have to read this, I can read this as an absolute value of 4. What this means is the distance between 0 and 4. How many miles? It's a 4 miles. So the parenthesis, keep in mind, is different than this 2 vertical bar. The meaning of 2 vertical bars and the number inside, meaning the absolute value. Let's look at on the left side. If you read this problem, now I'm reading this as a negative absolute value of -4, which means you're driving 0 to -4. Now remember, when we talked earlier, the distance is the same. And therefore, the absolute value of -4 comes out to be +4. Let's look at this again. I changed the number to 6 and -6 this time. Now, we already know that the absolute value of 6 is a 6 because it's the distance from 0 to 6. Now, what happens if I put the negative sign outside? Now I'm saying what's the opposite of absolute value? Meaning, whatever answer I wrote on my right side, I will also make that opposite. So the answer on the right side, 6, will become negative. The key thing is to remember is whenever the negative sign is outside the absolute value symbol, you want to carry over in your answer. Let's try one more. This time, I will take absolute value of -6 equals 6, which we did earlier, meaning a distance between 0 and -6 is a 6. Now I'm going to have a negative sign outside the absolute value. So opposite of the absolute value, keep in mind this is not negative times negative, positive thing. That is only true for parentheses and not the absolute value. You want to carry this negative sign on your right side. The answer becomes negative 6. Now let's find the additive inverse, which means the opposite, and also we'll find the absolute value for the same number. Let's look at the first example. Negative 19, I'm asking you to find additive inverse, meaning the opposite, and then we'll also find the absolute value. The opposite of negative 19 is positive 19, and the absolute value of negative 19, the distance between 0 and negative 19, also equals positive 19. Let's try one more example. 98. First thing, what's the additive inverse? Meaning the opposite of 98, that will equal negative 98. Absolute value of 98, meaning distance between 0 and 98, is obviously positive 98. Let's take some more example understanding the absolute value. Let's simplify. This problem I'm reading as absolute value of negative 25, meaning the distance between 0 and negative 25. The answer should be positive 25. Now, sometimes you have to simplify inside the absolute value first. In this case, I will do 9 minus 4, which is 5 first. So the absolute value of 5 will be 5, but because there is a negative sign outside, I'll have to bring that in my answer, which will make my answer negative 5. Let's look at the number 3. Here, I have a negative sign and then absolute value of negative 11. Keep in mind, this is an absolute value. So absolute value of negative 11 is a positive 11. Make sure you bring the negative sign down. Final answer, negative 11. Let's try one true or false. Here I have negative 8 and negative sign is outside absolute value of 8. So this will be negative 8. And then that's greater. Then I'm asking what's the absolute value of negative 9, which is positive 9. Now this is what you have to identify if it's true or false. Negative 8 is greater than 9, which is of course false. So hopefully you understand the absolute value. If you need, you can repeat the video again.